In this lesson, we'll be discussing host defense 2, which is our adaptive immunity. So if you remember from the previous lesson, we have two parts to our immune system, the innate immunity, which was discussed in host defense 1, and then the adaptive immunity that we'll be discussing in this lesson. So as far as our innate immunity, this is something that is already present within the body. We are born with it, and it consists of our first and second line of defenses. First being things that block pathogens from getting into a portal of entry, like our skin and nasal hairs. Second line of defense being things like protective cells and fluids within the internal regions of the body that protect us from infection. Things like inflammation, fever, phagocytic cells. The innate immunity is nonspecific, meaning it's going to react the same regardless of what you're infected with. So regardless of whether you're infected with a virus or bacteria or fungi, these innate immune defenses are a natural process and will react in the same way. They are rapid, meaning shortly after you become infected, they will start to work. But unfortunately, they do not elicit a memory response. So if you ever do get infected with the same pathogen again, you're not going to have a specific memory response that will protect you in the future, so you can get sick potentially with the same pathogen numerous times throughout your life. We compare this to adaptive immunity. Sometimes you'll hear this called acquired immunity. So this is something that is created in response to exposure. So we are born with billions of T cells and billions of B cells, which make up the adaptive immune system. And as we're exposed to different pathogens throughout our life, those individual B cells and T cells become activated to fight off the infection. So if any of us looked at our adaptive or acquired immunity right now, we would all have different cell lines activated because we've come in contact with different pathogens throughout our life. Certainly some would be the same because some of us have received similar vaccines and come in contact with similar pathogens, but certainly we have been exposed to different things. This does again make up our third line of defense, which is regulated through T cells and B cells, which is highly specific, meaning each individual T cell and each individual B cell is designed to respond to a specific pathogen. So you have one T cell and one B cell that will respond to the rabies virus. You have one T cell and one B cell that will respond to the measles virus. Hopefully those cell lines never have to get activated, but if they do, they will specifically respond to those infectious pathogens. It is slow to activate, typically between 1 to 2 weeks. In order for this portion of the immune system to become activated, antigen on the foreign pathogen has to be presented to cells within the immune system, typically T cells. And since only one cell is responsible for fighting off that specific pathogen, our immune system has to kind of find the needle in the haystack and find the right cell line to activate. And again, this can take some time, but once that cell line is found, the activation processes will take hold and eventually antibodies will be produced to fight off the infection. The good thing is, even though it takes a little while longer to activate, it does provide a long-term memory response. So should you ever get sick with the same pathogen again in the future, there is a good chance, assuming the pathogen has not mutated, there is a good chance that those memory cells will be activated right away to produce instantaneous immune defenses to fight off the infection before you even know that you have it a second time. So if we had to describe adaptive or acquired immunity in 2 words, it would be specificity and memory. So this portion of our immune system is highly, highly specific, meaning that it is going to respond, you have specific cell lines that will respond to specific infectious pathogens. So if we get infected with the varicella zoster virus, which causes chickenpox and eventually can lead to shingles, our body is going to respond and fight off that infection and produce antibodies to target that virus. If we later on go and get infected with the measles virus, the antibodies that were made towards the varicella-zoster virus are not going to recognize the measles virus. In order to fight off the measles virus infection, you would need to activate the proper cell line that is designated for that specific virus. So again, it's highly specific. We have individual T cells and individual B cells that are specific for all the different pathogens. And in order to fight off those pathogens, you have to activate those specific cell lines. And eventually, that will lead to the production of antibodies to fight off that infection. But again, those antibodies are designed to fight off that specific pathogen. They're not going to cross over and give you protection to other infectious pathogens. Another important word to associate with adaptive immunity is memory, meaning with adaptive immunity, when these cell lines get activated to fight off an infection, it does lead to the production of memory cells. And those memory cells will circulate in your body for a period of time. It kind of depends on the immune system and the infectious pathogen for how long the memory will last, but many memory responses can last a lifetime. But those memory cells will circulate throughout your body, and if you ever get infected with the same pathogen again, the cell lines will become activated right away, start producing antibodies instantly to fight off the infectious pathogen before you even know that you are infected, and certainly before any signs and symptoms come about. So memory exposure gives you lasting immunity. So for example, if you would ever get measles, you would obviously get sick the first time, but you would produce antibodies to fight off that infection. But again, those memory cell lines would exist in your body for the rest of your life, so if you ever got infected a second time, those cell lines would become activated right away and produce antibodies to fight off the infection before you even knew you were sick. So how does our adaptive immunity come about? It can come about in either an active manner or a passive manner. So with active immunity, we are going to activate our own cell lines. So we are going to activate in response to a pathogen, our own B cells and our own T cells. And this will typically result in the production of our own antibodies to fight off the infection. But the main thing is in active immunity, you are actively activating your own cell lines, your own T cells, your own B cells, to fight off the infection and build your immune response, build your adaptive immune response. So this active immunity can happen in two ways, naturally or artificially. So naturally acquired active immunity would be as simple as just going out and getting sick with an infectious pathogen. So you go out and you get the flu, you get sick, your body activates the cells in order to fight off the infection, the T cells and the B cells. Eventually you produce antibodies to fight off the infection and you get better. Again, those memory cells are going to be present in your body now, so that if you get infected a second time, assuming the virus hasn't mutated, you will have protective immunity. So naturally acquired active immunity is just as simple as going out and getting sick naturally with an infectious pathogen and building immunity after that infection. Artificially acquired active immunity occurs through getting a vaccine. So you get injected with a vaccine, and that causes your immune system to produce antibodies and memory cells towards usually a portion of a bacteria or virus. So that way, if you ever get infected with the real bacteria or virus in the future, those memory cell lines will become activated and antibodies will be produced to fight off the pathogen, again, before the signs and symptoms and illness even take hold. The downside about active immunity is it does take several days to several weeks to fully develop. So typically with naturally acquired active immunity, you do get infected. It takes several days to several weeks for your immune system to fully kick in, and during that time you are actively sick. Same thing with a vaccine. If you get a vaccine, you're not protected the next day. It can take upwards of 2 weeks for the full effect of that vaccine to take hold as far as providing you a protective immune response. So it does take a little while to fully activate. And again, a lot of that is because our body has to find the appropriate T cell and B cell lines to respond to the infection. But the good thing is, once it does activate, it does give you that long-term protection, that memory response, which can last years to potentially even a lifetime and protect you from getting sick with the same infectious pathogen over and over again. We can also get immunity through passive means. So passive immunity occurs when we receive antibodies from another source. So in passive immunity, you are not activating your own cell lines. So you are not producing your own personal antibodies. Instead, you are receiving antibodies from another source. And again, this can also happen naturally or artificially. So we have something called naturally acquired passive immunity. In naturally acquired passive immunity, antibodies are going to be given to a child from their mother, either through the placenta or through breast milk. We also have artificially acquired passive immunity, which is typically done through infusions with monoclonal antibodies. So if you are sick with a disease, they can basically transfuse antibodies designed to fight off that specific pathogen into your body. These antibodies were made in other humans or other animals against the infectious pathogen, and then they are injected into you to fight off the infection. This technique was used during the COVID-19 pandemic. But the key thing is, with both of these routes, you're not producing your own antibodies. You're getting antibodies from another source, whether that other source is a mother to child, which is more of a natural way, or artificial through some type of injection of antibodies made in another living organism. So it does not require activation of T cells and B cells because you are getting them from the other source. The good thing about this is it does provide immediate protection. So as soon as those antibodies make it into your body, they can start binding to antigens on the pathogen and leading it to its destruction. So you don't have to wait that 1 to 2 weeks. You start to get instant effect. The downside, though, is because you're not activating your own T cells and B cells, you're not going to get a memory response. Yes, you will get immediate protection, but you will not get a memory response. In order to get a true memory response, you have to activate your own cell lines so they can create memory cells. So unfortunately, with this route, should you get infected again in the future with the same pathogen, you are going to get sick all over again.